Hello, everybody. Welcome to another Bitcoin Core Review Club, where we'll go through some of the PRs to understand Bitcoin Core a bit better. Thank you, everybody, for joining in. And today we have the part two of our last review club, where we talked about descriptors and Miniscript in general. So if you haven't watched that part, we have the YouTube videos out there, so check that out to get the general context. We also like talk about descriptors again for a bit, and Miniscript, but this time on part two we are going to like look inside the code base and try to understand how the Miniscript descriptor thingy looks like inside Bitcoin Core. We'll not get like too deep into it, like there is a lot going on. It's a big data structure and algorithm kind of problem, and where it's mostly about a parsing logic, how to parse a certain kind of string and to transform them into Miniscript. So before we get started, so anybody want to like in like gist out what a descriptor is, just to summarize our last conversation? Emil, I think like you can go ahead and give a shot.
Uh, so descriptor is a way of basically telling like the derivation path of the public key, right?
Mm-hmm. Mm-hmm.
So that you can basically, it helps in sharing, so that the same key you can use in multiple wallets, if you
Right.
know the descriptor, right?
Yeah. Not only just the derivation path. So let's just go and take a look at the descriptor documentation. This is inside Bitcoin Core docs directory and descriptor.md, where the descriptor doc is there. It also like this is also another important part, right? The type of the script pub key, because from a single public key you can create different types of script, right? So you also need to communicate what type of script it is. And then if you put in an xpub, you can put other kind of textual information also. For example, you can put multi to identify, like create a multi signature script with these two public keys or these three public keys, and it's a 2 of 3 multi-sig, so multi of 2 for 3 public keys. So that's a very concise way, and put that whole thing into witness sh. Now you have the entire description of what your script pub key look like inside the transaction output, and that's the information that the wallet needs, right, in order to track all the transactions, show you a balance and addresses and all these things. So yeah, that's a descriptor. And then when we add an xpub, then we can do the BIP32 magic, and this encodes an n number of pub keys. By n I mean like a large number, 2 to the power 32 or something. And all these pub keys will be unique pub keys, and they can be derived from this information. And this wildcard is basically, this marks like this is a derivable xpub, and you can derive stuffs out of this xpub, and each derivation index you go from 0 to all the way to 2 to the power 32. For each index you will get an unique pub key, and then you create a pkh, public key hash, script type of that public key. So that's generally descriptor. And last time we talked about how descriptors are useful, how descriptors, and including with Miniscript. So how do you guys like differentiate in terms of explanation about descriptors and Miniscript? Where are they same, where are they different?
I think it looks similar.
Yeah. And it's syntextually also very similar, but the way I think about it is like, I think like this entire thing that is inside the bracket of a descriptor, the first bracket, is a Miniscript. So a descriptor is this whole thing, and the Miniscript is this part, like the one that is describing multi with xpubs. And this is a valid Miniscript, right? So this is a multi-signature Miniscript over there, and then sorted multi. So a descriptor is basically a script type wrapper on top of a Miniscript. And inside the descriptor, what we talk about are mostly Miniscript. When you go into taproot, each like the taproot thing is like, this is the key path spend, and this is the script path spend. And the script path spend is basically a miniscript, sorted multi A, two of two. Yeah, two public keys and two, yeah, two of two. So this is a key path spending, and this is describing this one script path spending. And that is like under the taproot descriptor. So this is how it makes all of this come fit together. With miniscript and descriptor, you can with a string kind of representation, you can express what your script pub key outputs are. And with that information, if a wallet knows how to like read descriptors or work with descriptors, parse descriptors, and then you can just copy paste this string to from one wallet to another, and your entire wallet will be basically reproducible in the new wallet. And right now how you do it is by doing the same thing with the seed. But when we are into the Bitcoin, the smart contracting world, right, where we are trying to do smart things with Bitcoin, not just like public key and signatures and send money from A to B. We are also trying to create contractual information inside Bitcoin. You quickly realize like this has been like historically the problem. Like, how do you like one back up the whole thing? Because it's not just about seed anymore, right? Seed is not enough information to restore your entire wallet. You also need to know how the script used to look like, and so how to back up this whole thing, and at the same time how to make it interoperable. So if you have a multi descriptor or multi signature wallet, and the wallet goes out of business, right, and the wallet software dies down or something bad happens, and you want to like store your fund into or restore the fund into another wallet, how do you do that? And there is no good way to do it right now. And that's why like Bitcoin multi-signature wallets and this kind of like smart contracting system are not ubiquitous in the market. And so descriptor, yeah, go ahead, anybody, any questions so far?
No, we are still covering the first. We are revising the first.
We are
part.
just revising the first part. Yeah, we are just going through the revision of the first part. Eventually we'll go to the code after that. We'll not go into too much details of the whole thing, just to revise and remember what descriptor and miniscripts are.
Just one question, like which is very generic, but right now most of the hardware wallets that we are using, almost all of them have mnemonics, right?
Mm-hmm.
So how do you foresee it changing? Like, will there be new consumer companies, consumer hardware devices which will be coming up with descriptor?
Well, so the way it's happening right now is like all the hardware vendors are like adding miniscript support. So if you have been following in Twitter, in Coldcard and Ledger, I think Ledger was the first one that added miniscript support into it. And so eventually, in order to like do this magic with hardware and stuffs, the hardware wallets needs to understand how to handle miniscript or how to parse and like operate with miniscript.
That, like, for a user to understand and store output descriptor, right now it's not super simple. It's not as simple as storing 12.
Right, yeah, and that's a trade-off of like trying to back up and make contract information interoperable, because you cannot it's just like the seed does not have enough information, so you have to put the information somewhere, and that's the open question. Like when you are doing more than just passing amount from A to B and you are trying to do complex scripting, the miniscript, the whole descriptor can be quite large, right? And it's not trivial to like writing 12 words, and you cannot make writing 12 words like you cannot screw that up, but you can like totally screw this thing up and trying to copy paste it, trying to store it somehow. And then this information is sensitive, right? Because everybody who has the string, who has a copy paste of this string, if you don't have like exprivs or private information inside it, then you are safe. But if your privacy is gone, this becomes an watch only wallet, right? So anybody with the string can trace all of your transaction output, can see what are the new transactions coming in, how much you own. Basically it's a giant privacy leak. And then if you have private desk, like private informations, maybe instead of like these are instead of pub keys, if this was private keys, then you're screwed basically. Then it's as critical as a mnemonic, and then you have to have all those safeguard around this thing, and all these things comes in. But so far, like the problem of doing that is like you can always create your own application, your own solution on how you wanna like back up your own complex scripting mechanism as a wallet vendor or a wallet developer, right? But how do you generalize it? That was the problem.
I think it's, like I was listening to a podcast of Chow with Steven Levera, and he was mentioning that there are a couple of standards coming in
Mhm.
to turn these output descriptors into some sort of mnemonic. It will be longer mnemonic. It's not going to be 24 character.
Yeah, okay.
It's not finalized, but there are a couple of proposals, and people are trying to figure out.
Right. Yeah, I like if that's the case, I see like it's probably it's gonna be more than 24.
Absolutely, like it
Yeah,
will be like,
it will be a big list of word, a page worth of word, if depend on how big your complex policy is, right? Another thing like I was exploring was like maybe the easiest thing to do is this kind of structures, in this kind of stuffs, you do not want to keep a lot of money. So this should not be inside your cold storage anyway, but your hardware device should be able to sign with this descriptor. But the easiest thing is like encrypt it, and via password, only the public version of it, encrypt it via password and put it into cloud storage. And then if any one of them get leaked, means like the password that is encrypting this public string get leaked, so now you have privacy leak, just change the xpub into something else, and then redo those communication again with all the parties. And yeah, like that way, like I didn't envision like trying to mnemonize it, because that's gonna be, I don't see like people eventually putting this in paper anyway. I see like they will rather put this as an encrypted format in some cloud storage or somewhere. But yeah, like that's just my opinion.
okay, yep. Hmm.
Anyway,
I
let's
have
yeah, go
okay.
ahead.
Small thing regarding like contracts, like time locks cannot be done with miniscripts, right? That is
Yeah,
using the
yeah,
version.
yeah, can
Oh,
be
it can be.
totally any
So it's
kind of
not the
contract.
version.
Yeah.
I thought it was a version field which sets time locks, right? No.
Yeah, it does. Like you were both right. Like the version field does set the time lock, and by miniscript you can also encode time lock information, right? So
Oh, okay.
so you can have a script like older. Here you can have a like another script called older 100.
Oh,
That
yes, yes,
that
yes. Okay,
means
okay.
like after 100 blocks, this path is
Got it.
spendable.
Oh, okay, okay. Got it, got it.
Yeah.
Okay.
Raj, so any sort of contract can be converted into Miniscript, right? Even DLCs.
Yeah, even DLCs, even Lightning can
I,
be
I saw an example for Lightning.
yeah. So Lightning, they are like actively trying to make Lightning wallets like descriptor based, but by trying to do the Lightning via Miniscript. Any kind of contract, like Miniscript is a generic language, and any kind of contract that is like expressible via Bitcoin scripts can be written in Miniscript. For those people who like missed the last review club, we really looked at this cool stuffs. It's,
Yeah,
okay,
this is really cool.
there's an actual page like that. Okay,
I think it's
it's
mentioned.
called min.sc. Yeah, in min.sc, this is like a web-based tool for high-level like Bitcoin smart contract scripting. And if you type it over here, you see this is the Miniscript descriptor, and this code get translated into Miniscript descriptor, which get translated into the actual Bitcoin script, right? So you can see like how difficult to write this Bitcoin script. If you have to this is a liquid federation, right? If you have to write a liquid federation via, and they actually did it. They wrote it via script back then, and right now you can just like programmatically define the script like this. So this is a federation which is a 4 of 5 public keys. This is a recovery which is a 2 of 3 public keys, and this is a timeout which is older 3 months. And your miniscript, your final contract looks like likely via federation or after timeout via the recovery path. That's it. That's liquid, right? And same thing, you can write lightning also. I think like they have an example
Scroll
of
down.
lightning somewhere.
Yeah, if you scroll down, like there are all kinds of policies.
Yeah, so they have like lot of examples. You can even define functions. Like this is where it starts looking like the solidity code of Ethereum, right? You can define 2 functions, and your like whole thing can be a function of a function of a function, and you can chain stuffs together. So this is really powerful. Like this, like miniscript itself isn't not like handy to write by yourself. You can, like, it's not that difficult, it's much easier than Bitcoin script, but this is like something that where like the entire thing is abstracted away, and you can, so this is the traditional payment based lightning. So this is the HTLC. Let's try to play it and see how the miniscript will look like. That's fun.
Something that it reminded me was, so in Ethereum, there's something like all the scripts are standard ERCs, right? And they have like a lot of auditing companies are out there who offer consulting services. So if you're writing a piece of code which is non-standard, then basically employ one of these auditing companies, and they ask you to pay a lot of money, $100,000, $200,000, like up to the norm. Back Consensus has a venture in auditing,
Right.
and that's what they do, right? So any non-standard ERC, they will sort of vet, and only after vetting done by one of these auditing companies that the
Yeah.
contract is put out.
Yeah. Yeah.
That all that is completely not needed. Like if people are building contracts on Bitcoin, then you can very easily see the Bitcoin script, and these are like far more standard, and there's very less chances of
It goes even better. It goes even better. So what miniscript also does is, like, miniscript does sanity checking. And sanity checking is a very rigorous check on the Bitcoin script that nothing can go wrong in that scale. And the good thing about Bitcoin script is, like, Bitcoin script are deterministic. Unlike Ethereum, it's Turing incomplete. Because it's Turing incomplete, you can statically analyze it. So you can, like, even programmatically determine whether a script is safe or unsafe. Like you can, like, fuck up in the logic, right? You can, like, screw up in the logic and do something very stupid over here, and so the fund goes to somebody else that it wasn't supposed to. But if you have the logic right, then nothing at the Bitcoin script layer can go wrong. This is a guarantee you do not have Ethereum in Ethereum virtual machine. And they lived with that fact because they wanted to run loops to run any generic program on the virtual machine, and that's the trade-off you get for running loops. So in this entire thing, you can do functions, and you can do if else clause, but you will never see like there is a loop. You can't do loop in Bitcoin. And the cost of, like, the benefit of that is, like, the Bitcoin script becomes statically determinable. It's not only, like, statically determinable for safety, it's also statically determinable for the satisfaction. And by that I mean, like, how much data is actually needed to satisfy the script, and by knowing that, you can predetermine what will be the fees of the transaction. And if you guys remember Ethereum, in Ethereum you have a concept called gas. And unlike Bitcoin, where you always know the transaction fee, in Ethereum you never know what the gas you should put. And you have to put more gas than the minimum gas that it's like the wallet is saying you. And if you have less gas than that, then your transaction will actually not go through, and you will, like, lose the gas, but your transaction will also not go through if you have not enough gas for the execution. And why do you need, like, gas budget for the execution? Because you never know what is the total input size that is going to satisfy the script. That's never the case in Bitcoin because it's statically analyzable. That means we also know the input size. That means we always can say what will be the fees of the transaction.
Yep.
So yeah, like, this thing makes, like, doing Bitcoin contracting easier. At the same time, Bitcoin contracting is, like, much limited in scope. Like, you can only do certain kind of like organizational structure and this kind of contracting, but at the same time it's very safe if you write the script right. And this is like HTLC. So this is how HTLC looks like in Miniscript. And yeah, and it's not that big. It's not that big. It's actually small. And that's all that Lightning is working on. So this is fun. Miniscript is like really powerful. That's why people are talking about it. That's why all the hardware wallets are like running for supporting this thing, because this allows us to do like this kind of cool things on Bitcoin, which is kind of like the point of using Bitcoin as a financial layer. You just don't want to like send around money. You also want to do contract. And so far, like the only way of doing contract has been like legal documents, like legal bonds, where all the parties are coming signing together. You can do the same thing via Bitcoin also, where nobody can cheat. So yeah, that's interesting.
Do you think at some point in time people will be able to make use of drop down tools to write like the code, or they will have to like use
I see like this is how they will do it. Let me see if I can find it.
the MIT wala thing, right?
This thing, I think they will have like a app that will go like graphical. And the graphics will look like this. So this is a demo tool
Yes, yes,
that
absolutely. Yeah, this
we
is what
created in BDK. And so this is like a big threshold scheme, and this is actually a full Miniscript wallet. You can actually sign transaction and broadcast transaction with it. I think this is connected to testnet right now. I have to check, I'm not sure. And you can actually do transaction with your own Miniscript, and this is the most simplest thing that you will need. It doesn't require much complex stuffs. You just define graphically what are the policy. So the policy, it looks like this is probably the liquid policy, either by all these 5 keys, 4 of these 5 keys, or 2 of these 3 keys, and when it is older than 6 block. So
was
either by this path or by this path.
it was a default Miniscript policy, right? Federation of 4
Yeah,
page or
that
the
was
same.
also Min's default. I think they played that default over here, and you have like these keys and stuff. So let me just toggle. Yeah, so you have like these keys and stuffs, leaves. You can have like this kind of leave, and then you have control flows, weight, threshold, and things. And then you can create it, and then you can go to home. Okay, so if you have the Miniscript right, then it will actually go to home and show you a balance. And this is your receiving address. This is the address of this Miniscript where you can receive fund from. And this is your test net. And then this is the spending policy. In the spending policy, you can check like how do you want to spend it, in which path. So these are the 2 paths, right? 4 of 5, do you want to spend in this way, or after time lock 2 of 3? So you can select them, destination, address, amount, and boom, it will actually create the transaction. But then here comes the challenge. All the participants, either via this path or via this path, all the participants need to sign that transaction, right? How to do that?
So you will have to give the functionality of like connecting it with your wallets. Would that be required? Like I'll have to connect the wallet which has this public like private key for this
Yeah,
address.
like for me, so if this is me, I will have my wallet where I will like only be able to sign for this public key. Then you have this wallet, you have this wallet. Maybe you are using different wallets, right? And the public keys are over there. How do we collaboratively sign together? So any guess? I'll give the answer. The most way to do it.
It's
You can
PSPTs,
use
right?
PSBTs.
Yes, PSBTs. And so
So
when we like, so when we create this transaction, I don't know if I can even create transaction. Um,
right now, does Elephant offer like connecting your hardware wallet and
no, no,
signing?
no, 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 no. This is just a demo. This is just a demo of like how Miniscript workflow would look like in a Miniscript vault,
I think
Miniscript
most
based
of the worlds
Bitcoin
are
vault.
not even supporting output descriptors right now.
Most
Very
of the wallet, very few wallet actually, like I don't know of any wallet that supports output descriptor where you can like import output descriptor into the wallet.
I don't think Trezor is doing that right now.
Uh,
Whether
Treasure, like I don't think so. Ledger has a Miniscript support. By Miniscript support in hardware, what I mean, what they mean is like if you give the PSBT to the hardware, the device will know by reading the Miniscript, or device will have a way to store the Miniscript and the PSBT and combine this together and figure out how what signature to put where of the PSBT and the transaction. So that's what they mean. It doesn't mean like you can create your own Miniscript wallet inside Ledger. It just means like if you give the Miniscript and if you give the PSBT, it knows how to sign it.
okay,
So here, like in the signed transaction, like when you create this transaction, I'm not sure whether it will be able to do that. Let's not do this guy, but this some destination address we have to give, and it will also not create transaction because there is no UTXO. We have to get a balance into this and then it will create transaction. But anyway, like this is like a example interface, and you can imagine this happening in the mobile wallet also. And there would require, like in the merge and broadcast, like all the PSBTs you have to paste here and then get merged. So all the PSBTs that came from different participants will get merged, and the final PSBT will be displayed over here, and then you broadcast the final transaction. So it requires communication between all the participants of that policy, right? So, and generally Bitcoin wallets does not do communication. Like wallets don't talk to each other, but whenever you are in a multi-party world, you need to be able to talk with each other. And so yeah, so that's like those are like the open questions and open problems around PSBTs and miniscripts. And you'll eventually see more products and more solution getting matured out on trying to do this. And but yeah, like this is totally possible. Like it's not impossible. Like nobody has came up with a standard way itself. And also like the industry is very new to Miniscript, although Miniscript has been around for what, like 3 years now, and it's been in development and it has been matured for a long time. And but industry is slowly catching up, and they also have to come up with use cases, right? You have to come up with like valid use cases so that people use it, because it's actually more complicated use of Bitcoin than just storing in your private key. So it also has to come with a good use case.
yep.
Okay, so yeah, we did a bit of like general description on Miniscript and descriptor again for a recap. So we'll get into the questions and the code this time. So before that, if anybody have any quick short question.
No questions.
Okay, cool, we'll go ahead. So before jumping into the questions, I felt like it will be probably easier and more enjoyable for us to in general like have a tour around the code base of descriptor and miniscript, and try to understand what is there and how does the whole thing look like, because like there is a lot of moving parts going on, and most of these questions are like a bit of C++ specific question. So we might not know a lot about miniscripts and descriptor, or in general about the coding context of that part of the code by going through the question. So we'll get to the question, but probably more helpful if we just go through the files first. So to start with, the major chunk of like miniscript and descriptor are happening around these four guys, like descriptor.h, descriptor cpp, miniscript.h, and miniscript cpp. Is my screen visible to everybody?
Yes.
Okay. So descriptor.h, if we take a look at the outline, descriptor.h has a very simple structure. It has a definition of descriptor. What does it mean by a descriptor? And this is an interface that like handles the whole descriptor. So this is a representation of a descriptor, how it looks like. It does not have any uh, any private data members. I might be wrong on many things when I'm like talking with this code, so feel free to correct me if you guys know more context around this part. And it seems to me like the structure descriptor does not have um, any member, and it's a virtual class, right? So it's basically an interface that gets implemented on other classes. That's the main part. And then we have this parse function, and this parse function is like the major parser that parse a descriptor string including private keys and put in the output variable. If the descriptor has a checksum, it must be valid. If required checksum is set, then checksum is mandatory, otherwise it is optional. If parse error occurs or the checksum is missing or invalid, anything else is wrong, null pointer is returned. So this is one of the like crux of descriptor parsing. So with this you go from the string of descriptor to the descriptor implementation. And this is a helper to get the descriptor checksum. This is another function to infer descriptor. So it says like find a descriptor for the specified script using information from the provider. So this is like the reverse way around. Usually from descriptor we can generate the script pub key, and this is about what happens if we have a script pub key and something called a signing provider. A signing provider is something that has signing capability and can provide signatures. And if the signing provider has enough information, then from a script you can actually like recreate the descriptor. Maybe like if you got the script from a derivable descriptor, and this is a specific script with a specific pub key of a derivation index, if you go back you might get the descriptor with the specific pub key instead of that xpub, right? So that's the like, but that there's a way to infer a descriptor from a script given enough information is provided in signing provider. So this is descriptor.h on broad, and there is a thing called descriptor cache. And this descriptor cache is basically a structure which stores the xpubs and all the information, the key information that is encoded inside the string. Is basically for each descriptor they maintain a cache, and this cache has some API, and but it basically about all the information that you want to know about a descriptor. So this is descriptor.h in broad. So anybody have any question at this point? So this descriptor.h wasn't like added in this particular PR. There were some changes that was made. I'll try to like find the PR in the timeline also. This guy was on so descriptor.cpp later. Yeah, miniscript support to output descriptor. Okay. And this is like the change that happened in descriptor.cpp. In descriptor.h, if we do like in this PR, descriptor.h, so this is showing me descriptor.cpp. Okay, in this PR descriptor.h didn't got changed, and that is also visible from if we go to the change set of this PR. So descriptor.cpp had a bunch of change. We'll try to understand overall what this change mean, not into too much details. There's a lot going on, and miniscript.h has few changes inside it. And the entire point of this PR was like the descriptor functionality was already there. So Bitcoin core already knew how to parse descriptor, and they added the miniscript into the existing descriptor. And there has some checks over there. But anyway, let's go back to the code. So descriptor.cpp, and descriptor.cpp is like, if we look at the structure of it, so there is a lot of different kind of descriptors, and each structure defines its own descriptor, and then we have some functions. So here's a thing called pub key provider. Like it's an interface that like provides pub key for a descriptor. And then the major thing, there are certain other kind of like origin pub key provider, constant pub key provider, derived type. So derived type is basically saying like whether our xpub is like derivable or hardened derivable or unhardened derivable. Details of that will be found in BIP 322, sorry, BIP 32. And so yeah, so that defines like what kind of derivable descriptor we have. And then a BIP 32 specific public key provider, which basically is a pub key provider that provides xpubs, right, and all the xpub specific information. So it's a pub key provider. Instead of providing pub keys, it provides xpubs. And then the major thing is like descriptor implementation. So this is a class that is like an inheritant on the descriptor, which was an interface. So this is like the class that handles all the data and also like implements the descriptor interface on top of it. So this is the main class, but this is not also not the final class. So later on, all the other type of descriptors are inherited from descriptor implementation. So this class has like a lot of members and all the operations that you want to do with descriptors. And then we have a lot of like inherited classes. Any questions so far?
Now I'm confused as to what the new change is. Because it looks like most of it was there already, right?
Yeah, we'll take a look. Most of
Sure,
it
sure.
was already there. The new change was actually very small. And so here we have like different kind of like descriptor. So address descriptor, like descriptor that content addresses, and there can be descriptors like that. Raw descriptor that contains the script pub key, like the like a raw h, like raw hex of the script. That's also a valid descriptor. Then we have the public key, pkh, wpkh, combo, and then multisig, wsh, taproot, and all these things. So all these descriptors are basically like an like implemented on top of like the descriptor implementation. So the new thing that got added in this PR is like the miniscript descriptor. It's the descriptor that has a miniscript inside it. So all these previous descriptors are about public keys, right? The WPKH, you have either an xpub or a pub key. But in miniscript, you can have descriptor that has like miniscript inside, which can have multiple xpub, multiple pub keys. In fact, miniscript is a recursive structure. A miniscript can contain more miniscript inside it. So that's what it's called, like a miniscript node. A miniscript node is like you can trace from one node to the node that is inside it. Another way of like trying to explain it, probably, let me see. So you can see like and or to this part, like this entire thing is one miniscript. But then again, this guy is another miniscript. This guy is another miniscript. This guy is another miniscript. And this guy is another miniscript. Right? So the top level miniscript is composed of internal miniscripts. So actually, like this and or, I don't know what and or means, but this whole thing, no, this one thing is probably one miniscript. Let me check the delimited. So public key is ending over here, SHA-256 ending over here, and of this or older of this. So anyway, the entire point is like in a one miniscript, you will have multiple miniscript inside, and that miniscript can contain more miniscript, and then it's a recursive structure internally. And that's how it is coded inside this, the miniscript implementation. So this miniscript node is what is called as like the, as one single miniscript. So this is like the top level miniscript load, and you can go deeper into one miniscript at a time. So it has like few other details around it, like parsing the miniscript. And parsing the miniscript is probably the biggest another change that happened. This key parser was the change that got added. So as we are talking about change, let's just look at the change itself. So this is the major part of the change. So they added a script maker, then string maker, and this is like the context for converting a miniscript descriptor to its textual form. And script maker, the context for converting a miniscript descriptor into an actual Bitcoin script. So the script maker takes the miniscript, transform into a script. The string maker takes the miniscript, transform into a string. So these things got added new. And then the entire miniscript descriptor implementation was added. And this was the new part. So this is like what they meant by fitting the miniscript inside the existing descriptor. Questions, doubts, brain scratches?
So should there always be one top level node and the like branches, or can there be?
Unless it's taproot. In taproot case, like the descriptor will look like multiple nodes, but if it's like WSH, then yeah, there should always be one top level node and then branching inside.
So I think this is. I was thinking, is it similar to like how the compiler works, like abstract syntax tree and tree shaking that?
Kinda, yeah, in a way. Probably more similar to that than you might have thought. And if you look at the actual miniscript implementation, um, you might actually find like something like that is happening.
Yeah. Okay.
I'm not too sure though. Like I haven't like dug into those details,
Yeah.
but
So that's that's
yeah,
my whole thing.
yeah. So this was the change over here, and then later on they added another change is like infer pub key infer. These two have been a move. So later, like here they have like they used to have this over here, and they just moved it up over there. Probably that is more cleaner. And then they added this thing called key parser. And this key parser was another big thing that got added. And what the key parser do is the context for parsing miniscript descriptor either from a script or from the textual representation. So if you can give the Bitcoin script, it will try to parse a miniscript descriptor. And then if you give a text, it will try to parse a miniscript descriptor. So yeah, so that was the major chunk over here that got added. And this was like there is this big parsing function, right? This big parsing function, the parse script that we just talked about in descriptor.h, it used to already parse all the different kind of descriptors. And then here it added this new process miniscript like new branch. Like this is an entire scope on its own. If none of the previous thing actually works and returns, then it will try to parse as a miniscript of the string. And here you can see like node is not sane. So there is a way of like determining sanity of a miniscript node, right? And if the node is not sane, then the parsing logic itself will go wrong and say like it's invalid for variable reason. And many of the reasons are like that. So a malleable witness crate exists. So if there is a witness that is malleable, it can identify that. Then witness without signature exists. So if there is a witness path, like there is a execution path that doesn't require signature, it will not work. Content mixes of time lock expressed in blocks and seconds. So time locks are used by both blocks and seconds. That's something like should not happen. Content duplicate public keys should not happen. Need witness that may exceed resource limit. So a witness that is like so big, or like the input data of that witness is so big that it will like exceed resource limit. So that is also not allowed. And all these things are actually like statically analyzable from the miniscript node. So yeah, so that's where like this small tail logic got added inside the already existing descriptor parser. here, parse script. Question, thoughts, doubts?
Okay, so the part where, like, I guess converting from the text into the script was already there, and like the new code is just to basically check the validity and maybe I think derive the public keys. So with that, is it?
Mm, this code is mostly about like creating an miniscript descriptor at the end with the node and the keys. Like finally it will return an unique pointer to miniscript descriptor. Miniscript descriptor is an object that is a descriptor that contains miniscript inside. So yeah, like the parse one is like this entire code is about like getting a string and getting a descriptor out, and this part of the code is about the same string but getting a miniscript descriptor out of it.
Okay. So basically taking an input of the text or string
Yes,
and then converting it into this
into a
descriptor.
miniscript descriptor. Yeah.
Okay, got it.
Yeah.
Okay.
Yeah. Any question around other parts?
So, like this addition, the miniscript part addition that has been done, uh, existing descriptors are kept as is.
Yes.
Like, there's no change.
No change in the existing descriptor code. Yeah.
So, miniscript were designed in such a way that existing descriptors were used as is, and only new descriptors were added.
No, actually, no. Like, there are some overlap between the miniscript syntax and the existing descriptor syntax, and this is actually interesting. It was a question I think inside this in the also yeah. For example, consider a policy. Oh no, not this one. Mm, oh, I guess it wasn't a question, but the question was there can be strings that can be parsed both as descriptor or as miniscript. They look same. So what will happen when a script that can be when there is a string that can be parsed as a descriptor and also as a miniscript descriptor? So in that case, it will be first parsed as the descriptor in these branches. Like if in any of this if else branch, if it's a valid descriptor, then it will parse through via them first before that's why like the miniscript logic is added at the end. So this logic will only capture all those strings that did not hit any of the if clauses above.
Okay, so first existing descriptors will be hit and checked
Yes.
for, and then only
Yes, if nothing hits in the existing descriptor if clauses, then only like the execution will go into the miniscript branch, and if that also doesn't hit, then it's a failure.
okay, got it.
Yep. So if no more questions around this, we'll take a look at the miniscript.h file next, uh, which is quite big. We'll not take a look at the whole thing, just to show you how big this is. So miniscript.h is a file that basically like contains the entire logic of like miniscript, and this is the miniscript compilation algorithm, I would say. Like if you want to call that compilation, it's rather an one-on-one mapping, but this is a compilation of the miniscript that is going on. So from the string you have to like make sense of what the script and what the whole structure of that miniscript looks like, and from that miniscript you also have to like evaluate a Bitcoin script out of that structure. So how does that happen is encoded in miniscript.h, and we'll not go through the whole thing, it's like too big. We'll just um check few stuffs around, but it's just too cryptic for me to even understand what's going on. But I can see like these are like the miniscript fragments, like these are all the miniscript fragments you have, and each of these fragments are mapped to a specific Bitcoin script fragment. So SHA-256 If you get a miniscript text that correspond to SHA-256, this will translate it into op size 32, op equal, verify op SHA-256 of the hash, and op equal. So that's the whole Bitcoin script verification for a SHA-256 with a hash. Right, so this is how like each fragments are being mapped into different types. This is like the document, but it's happening internally inside the code. And it's a lot of like data structure and algorithm engineering. So the same thing also exists inside this Rust miniscript. And interestingly, these two implementations were written independently by different developers. And if somebody is more comfortable with Rust, they might even have like fun, like going through the Rust miniscript version of the miniscript logic. And this happens inside source policy test tutorial miniscript. And I'll have a hard time finding what it's happening. So yeah, I think it's happening all around these crates. But if you find like C++ hard to read, Rust will be like much easier to read if you are really going into maybe the interpreter inner. Yeah, could be. This is the miniscript interpreter written in Rust. And this code is like very structured, and this is like the de facto miniscript library out there for doing anything related to miniscript in Bitcoin application layer. This is how BDK has been the miniscript descriptor wallet, the first descriptor wallet library. It uses the Rust miniscript inside. And in any case, like if you want to like create a descriptor wallet or a miniscript wallet, you at least in the software level, application level, you have to either go by BDK, use that API, or like craft your own wallet API using Rust miniscript. So that's the same thing that is happening inside over here. And this is the C++ version of the code, but this is not like one-to-one copy. It's like written independently. So this is miniscript.cpp and miniscript.h, and this is miniscript.cpp, which is also another cryptic file where a lot of if-else clause are going on. Like not a lot of structures, but a lot of if-else, and the case statement matching is going on. So every fragment is getting matched, and then some kind of like magic that is happening here that I don't fully understand. And yeah, and that's how miniscript is working.
Even the comments don't make sense. It's like G equal to G or something.
Yeah, even the comments don't make sense. So yeah, it's hard until you are deep into miniscript or like designing miniscript or something. But yeah, like using miniscript is not hard, so that is a good thing. And even though writing miniscript could be like very hard. And what else? Miniscript.hcpp. Yeah, anybody have a question? Inside miniscript.cpp, now if we take a look at the changes that happen inside this PR, is so anybody asking anything? Okay, cool. So inside this PR we have like operator got added, right? So this is comparing two public keys, whether one is greater or one is lower than other, and then it used to check whether there is a duplication of public keys inside miniscript. And then it adds few things called a script maker, and we initiate a miniscript here with a simple integer as a key type, and it's a script maker that is making some script. And then the miniscript descriptor implementation. Oh, we are checking into miniscript descriptor. We want to see miniscript.cpp timeline. Maybe.
String maker and script maker is it takes the descriptor and then converts it into a string and Bitcoin script, right? That we covered earlier.
Yeah. Just give me a moment. I'm trying to figure out how I can get a Miniscript support in output descriptor. Okay. So this is the, I guess, yeah, this is the, yeah, what was the question you were asking?
We saw, I think, string maker and script maker. So that is to convert the descriptor class into string and Bitcoin script.
Yes. Yeah, you're right. Yes. So here they added a tree evaluation function, which is like doing some evaluation on the tree, and this is like using some lambda inside it, and then it's calling some up function and down function, and it's very cryptic. I couldn't like fully understand what it is doing. And then find an insane subnode. So given a node, can you find an subnode to that node which is insane? And that's also very useful for like sanity checking. Then some doc changes over here, and they moved this is valid top level from here. I think like probably it's not needed anymore.
So one doubt I think which all of us might have is what is the difference between insane and invalid?
Insane means like insane means like it's badly formed, I think.
I am guessing, but insane probably means that it does compute to something, but not what it claims or what it should have ideally computed to, going by the like.
Check whether the node is safe as a script on its own. So if is it a safe script, and validation satisfaction, whether successful non-valuable satisfactions are guaranteed to be valid. So it means like it can be satisfied, that means like the puzzle can be solved. And is sane means like you do not have like um problems like those, like you have like malformed scripts, or you have like witness that is like taking a too big input, or you have like a path that does not take any signature, right? So all this way that can be exploitable is covered in is sane.
So like syntax you can say is valid. No, yeah, validity I guess would be like syntax, and then sanity would be to make sure that like it's a good descriptor. I mean, good
Yeah,
miniscript.
yeah. Validity will be like if you done anything like that's the like there. If you done anything wrong in the syntax, then the parsing will fail. Like it's a malformed descriptor. Like the descriptor isn't not right, and
Oh, okay, okay.
and
So there
and
are three ways it can fail.
yeah, and is valid whether the check the node is valid at all, like whether like the node has like this max standards p2wsa script size is less than that, and whether it's non-malleable. And so validation satisfaction means like is valid, check check operation limit is good, and check stack size is good. And is sane sub expression is validation satisfaction, it's non-malleable, check time lock is not mix, and check duplicate keys is not there. All this combined is called is sane sub expression. Is sane means is valid top level, is sane sub expression, and need signature. So it's kind of like a combination of all this sanity check that happens over here.
Okay, okay, okay. So is sane is like the top. If it's sane, everything
It's
is
if
covered,
it's
I guess.
sane, it's good. Like it's
Okay,
good to
okay,
go. Yeah.
okay.
Yeah, and What else other change? So we'll probably not have time today to get into the questions. We are already at our mark of 1 hour. So these are the major changes that happen. It generally, like, this kind of PR takes a lot more than an hour to like go through and discuss it out. So yeah, I guess like we'll close for today over here, and we'll go for one more round of last question. Can be generic, can be code based, anything.
So really, there are no wallets in which you can like input a descriptor. I think that's a good
No.
project to try
Yeah, it's a good project to try. It's a really good project to try out there. There is
because
no really wallet out there where you can input a descriptor.
backend you can like use BDK to do
You
like
can
some
like, yeah, you
specific.
can use BDK CLI to create a toy around with it, but nobody like went like and created a
Okay, with the
production
UI.
level wallet and deployed it. There is a wallet called Padawan wallet, and this is also Thunder Biscuit's pet project. But I don't know if it supports like importing descriptor. I think probably it does, and it's the first BDK based like Android wallet created to like as a demonstration, like tutorial purpose, to show how a descriptor wallet will look like. But so far nobody have created one in production.
There was a wallet that he was telling me about that came from bowl.fun. What was that wallet? Last year's hackathon winner.
Mutiny wallet. Yeah, Mutiny wallet uses BDK, but it doesn't allow you to import descriptor. So you can use BDK and not give user to option the import a descriptor. You can like hard code a descriptor and say like my wallet is a multisig and it will always do a multisig descriptor, right? So in that way, many wallet uses BDK actually, but they don't do descriptor based thing. Like they have their own descriptor, they translate their wallet management into a descriptor and use the BDK library, and then feed that descriptor into BDK and use BDK in that way. But it doesn't like allow the user via the UI itself to feed the descriptor into the wallet so that you can create any custom wallet inside the same app. It's probably more complicated than that to actually do it in a production. Like lots of security backup and all these things have to be handled, but a good side project to try with nonetheless.
Yeah, I think the issue, like you said, is the use case. Like when you make it,
Yes.
there'll be just like 10 people who need it. So
Yes. Yes. That's the probably the biggest bottleneck of Miniscript right now. We don't have a compelling use case. Okay, cool. So we'll wrap up over here, and thanks everybody for joining in. This was a fun session. It was a bit deep, and we had a good session on descriptors and like introduction around the code base and stuff. So
I think
I
we have one more next time to cover the questions, if that's okay, on Miniscript itself. Or would you want to do something else?
I would probably want to do something else. Yeah, like no more Miniscript, and yeah. Let's have some fun somewhere else, and it's good to keep it varying and keep looking around. Yep. So stopping
Okay.
recording.